P equals m times v, where m is mass and v is velocity and p is momentum. For those, you don't have to write down all of these variables, but for the rest of them, all the rest of them are elastic collisions. We're going to do inelastic collisions later. Right now, we're doing elastic collisions. That's where they bounce apart. See, it says if it bounces apart, it's elastic. If it sticks together, it's inelastic. So this is elastic because you got two objects, and then they bounce apart, and then you still got two objects. When we do inelastic, two objects, and then they stick together. You can see the math even says they stick together. But right now, it's elastic, so let me show you this example. So if you have a 3 kilogram bowling ball going 2 meters a second, that's the first object it talks about. It doesn't really matter which one is M1 and which is M2, but because I mentioned it first, I'm going to say that this is M1, 3 kilograms. So I put M1 as 3 kilograms, and the M1 and V1 both are with object 1. So this is the mass of object 1. This is the velocity of object 1, so V1 is 2 meters per second. The other object just says it strikes a 0.1 kilogram golf ball at rest. So M2 is 0.1 kilograms, V2 is 0 meters per second because it's at rest. All the stuff it's telling you is all before the collision until it says blah, 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 blah. And after the collision, the bowling ball stops. So now we go over to the after variables and write down what it says here. So, okay, the bowling ball, I like to go back and check. That's the 3 kilogram bowling ball. So here's my 3 kilogram object. It was going 2, and now it's supposed to stop. So I got to make it say 0 after. There we go. One cool thing that makes this easier is the masses always stay the same. It's still the same bowling ball after the collision, so it's still 3 kilograms. Same with the golf ball. They always stay the same, the masses. Still the same golf ball, so it's still 0.1 kilograms. So the bowling ball stops after collision. How fast does the golf ball move after the collision? Before it was going 0, it's going to move pretty fast. And I know it's going to move pretty fast because thinking about what's happening here, it's got a 3 kilogram bowling ball going 2 meters per second. If you were trying to catch that, if it was rolling on the floor and you try to stop it, you probably want to use both hands. And if you got to stop it, you definitely feel it when it hits your hands because it's a bowling ball. To make that golf ball's momentum equal to that bowling ball's momentum, like for that golf ball to be as difficult to stop as that bowling ball would be, the golf ball was going to have to go real fast. So, and that's what's going to happen if that bowling ball stops and that golf ball takes all that momentum. Momentum is supposed to be conserved, so the momentum of the bowling ball is going to be equal to the momentum of the golf ball afterward. If the golf ball has stopped before and the bowling ball stops after. You'll see what I'm talking about when I plug the things in. Here we go. So, I'm gonna take some of these books over here. All right, I'm ready. Yeah, this is better. Okay. So, I've got a before side to my formula and an after side to my formula. Like I said, I really recommend you make a before column and an after column. And then in your formula, write just the formula. Don't plug anything in. Do that every time. Write your before label and your after label. And that way you know exactly where the stuff goes. Because I got before M1. I got before M1 right here. So before M1 is 3 kilograms. Before V1 is 2 meters per second. Before M2 is 0.1 kilograms. How do you say 0.1? Before V2 is 0 meters per second. And now we're on the after side. So after M1 is 3 kilograms. After V1 is 0. After M2 is 0.1. And V2 is what we're looking for. All right. Ooh. What I just did is the hardest part of it all. I probably did about 90%. 95% of the work right there because like what we have left to do is only 5% of the work because check this out. M1 times V1 has 3 kilograms times 2 meters per second. 3 times 2 is 6. 0.1 times 0 is 0. 3 times 0 is 0. 0.1 times V2 is 0.1 V2. 6 plus 0 is 6. 0 plus 0.1 V2 is 0.1 V2. So you can see it gets real easy after you write everything down, but it's real important to stay organized. Otherwise, with all the M's and V's and 1's and 2's, it makes it real difficult. So, okay, we got V2 times 0.1. To make that 0.1 cancel, I'll divide both sides by 0.1. 6 divided by 0.1 is 60, and that's velocity, so it's meters per second. And that's our answer. And yeah, that golf ball had to go real fast to match that bowling ball's momentum. 60 meters per second is real fast. One thing I forgot to say, when you're doing momentum at the beginning, that's just mass times velocity. It's kilograms times meters per second. The unit for momentum is kilogram meters per second. They didn't make anything fancy up like they did for newtons or joules or whatever. So you don't have to type out that unit name. If it asks you just for momentum, then you can just say the number and that's fine, because it's kind of a silly unit. The unit for momentum is kind of a silly unit. Any questions about this? Give it a try. Make sure to organize it just like this. I'll leave this up here. Please start that elastic collisions assignment.